Hi, so we are on the last part of our Newton's law, which is the transition to the third law of motion. But before that, we need to discuss a little bit of the second law of motion. So, humana ta sa second law of motion, which is about um, the using the free body diagram in identifying the net force and the acceleration of an object. So you use the second law of motion formula, or the F net, or the net force is equal to the mass times the acceleration. So humana ta ato nag-incorporate nato siya sa isa ka free body diagram na atong gidraw sa isa ka object. Okay. Now, that is nato yung mga i-add na mga, let's say, we'll add some information about that. No? So that is what we call the application of the second law. So asa man gina-apply ni siya sa second law. Okay. Now before that, I need to go back here, the law of motion, anxiety, and misconception. So most of the time, people tend to get confused by the laws of motion, no? So unsay ilahang parameters, unsay saklaw sa law of inertia, say saklaw sa law of acceleration, unsa ang ginamin sa law of interaction. Okay? And that is because all throughout our learning, we have what we call misconceptions. Okay, so what are misconceptions? Misconceptions are ideas, or I mean, yeah, ideas that you have learned before nga, or learned before siguro mga bata pa mo, na learn na ninyo siya, na acquire na ninyo na knowledge, and then it turns out to be not true. Okay, so na yung mga misconceptions na yung ano. So first na misconception na very common is about the misconceptions, or the misconception about gravity. Okay, so na yung mga misconception about gravity. First is, pag naana ka sa space, there will be no gravity. That is why you will float on space. Okay, so isa na siya sa mga misconceptions sa mga students. And that is because na dala na nila during maybe elementary years when they were kids, na nakita nila sa, let's say, sa isa ka video, isa ka movie na in space, the people there, the astronauts there, the objects there are not, um, are just floating around like that, are floating around. So, siguro, na na-think nila or nahuna-huna nila na maybe there's no gravity there. Kung na gravity, dapat na-pull na sila towards the Earth, right? So that is a kind of misconception. You know man, because even though that object is on space, there is still the force of gravity. Okay, so naagya po force of gravity even though you are in space. No? So because of those misconceptions, people had a hard time understanding the laws of motion, the three laws of motion, even though they are very easy to memorize. There's their laws, the statements, I mean, are very easy to memorize, like the law of inertia, the law of acceleration, and the law of interaction. Dali ra kayo sila i-memorize unsay meaning nila or unsay statement nila. But most people, they, let's say, dili nila ma-grasp dayon na idea. It is because of their misconceptions. Okay? So, um, now, isa sa may misconception nila in this law of motion, yung malilisod sila og grasp sa law of inertia, labi na sa law of inertia, is some people think that sustaining motion requires a continued force. Unsa meaning ana? Na ang meaning ana is, para mo continue og move ang isa ka object, need nila og force. No? So, para kunwari, sa atong makitan karon na once kunwari i-push niyo, mag-move ang isa ka ball. Then, after a while, you need to push it again para mag-continue ang iyahang motion. So, mao nang gina-think sa mga tao na you will need motion, or I mean, to sustain a motion, you will need a continued force. Hatagan nimo siya continuous na force. But that is actually incorrect. No? Incorrect na siya, or it is actually a misconception. No? So, nga naman, during the law of inertia na discussion ako, I have discussed that um, an object in motion will remain in motion unless there is an unbalanced force introduced. No? So, kung nag-move na ang isa ka object, dili na niya needed og another force because it will continue moving. So here, this is wrong. Kaya naa naman siya motion daan. So sustaining motion, kung i-sustain nimo ang motion, ipadayon nimo ang motion, ayaw siya hilabti. Ana siya ang sa law of inertia. And people tends to parang dili nila mag-grasp dayon na siya na idea ba kay maglisod sila. And that is because kani siya is naka-instill sa ilahang mind. Kani nga misconception. O nang maglibog sila sa statement sa law of inertia. Okay, so for example, we have here, during the discussion, student 1 suggests to student 2 that the object under discussion could be moving. Siya, pwede daw na moving siya. In fact, student 1 suggests that if friction and air resistance could be ignored because of their negligible size, the object would be moving in a horizontal direction. Oh, sorry. Okay. So, according to student 1, an object experiencing forces as described at the right, kani siya, could be experiencing a horizontal motion as described below. As you can see, these have perfect, pareho sila og spaces. So it means constant ang iyahang horizontal motion. Okay? So, ana si student 1, ang say point ni student 1 dire. Ningon siya, bisan ning ani daw ang iyang FBD or iyahang free body diagram, kani siya nga object might be in motion. Pwede na in motion daw gihapon na siya. Okay? And pwede na in motion siya, pwede pud at rest. Mao na point ni student 1. Na bisan kanira na mga forces ang present, pag ato ang ihawa si air resistance or i-ignore nato si air resistance o si friction, this will be the free diagram of that that object. Now, student 2 objects, arguing that the object could only have niingon siya na ang kani nga object is horizontal rin wala ni siya horizontal na motion, vertical lang. Tanawon nato ang iyahang free body diagram, duhara ang iyang forces. Duha nga vertical, no? So these two vertical forces are acting upon it. So student 2 claims that the object must be at rest. Kaya wala man kay makit-an nga horizontal niya nga forces. So si student 2 ni-argue siya sa student 1 na kani siya nga free body diagram or kani siya nga object is at rest only. Okay, so niya siya, no, that is at rest. Why? That is because there is no horizontal forces acting on the free body diagram. Okay, so after all, says student 2, an object experiencing a balance of forces because it's both 20 newtons will be at rest. So who do you think is right, or who do you agree with? Okay, so here both have reasonable claims. No, so tama man po si student 2, naay points si student 2, naapod points si student 1. But actually the best answer is student 1. Okay, so kani siya nga free body diagram. Kani siya, let me erase that first. This free body diagram pwede siya at rest or in motion ang kaning object. And that is because if katong point ni student 1 na if in-neglect nato si friction and si air resistance na pwede mo act sa horizontal plane or sa horizontal axis sa ato ang free body diagram, then kanila may mabilin sa iyahang forces. Student 1 is right, no? So pwede siya at rest, pwede po siya in motion. Okay. So student 1 is right. Student 2, tama man ang iyahang point, no, na balance na siya, so pwede na at rest. Pero wala man siya ni 2O kay student 1 na maski walay horizontal motion na makit-an diri pwede gapon siya maglihok, no? So wala siya ni 2O ana. So it means wala siya ni 2O sa three laws of motion if that happens, no? Kabalo siya sa katong part na balancing the forces about the free body diagrams, kabalo siya ana nga concept, pero si studente wala kabalo sa concept sa three laws of motion or the law of inertia particularly. Okay? Now next one. So imagine at the moment where there was no friction along B and C. Ni siya nga level din. And there was no air resistance to impede your motion. Impede means stop. To hinder, stop your motion. So how far would your sled travel and what would its motion be like? So if you're from point A, tapos magpa-slide ka to B, okay? So what will happen to your motion? It means if there is no air resistance and there is no friction, your motion will continue infinitely. Nga naman, because you're already in motion from A to B. In motion na ka na. Just the just being at the top of that plane, you will have motion pag imuhan na siyang slide dira, no? Because sliding is a motion. Sliding down is a motion. So when you are already in motion, then you will stay in motion as stated in the law of inertia. So wala may maka-stop sa imuhang motion kay walay in the first place walay friction, then wala po'y air resistance na pwede mag-stop sa imuhang motion. These are what we call one of the unbalanced forces na pwede makaguba sa imuhang state of motion, sa imuhang state. Sila ang mga pwede unbalanced forces na pwede makakuba sa imong state. So if you're at rest, then na siya unbalanced force, pwede siya mag-move ang isa ka object. When you are in motion, hatagan nimo siya unbalanced force, pwede mo stop ang in motion na object. That is why if there is no walay friction, walay air resistance is also a kind of friction. It is a special type of friction that is about air, no? So instead of a material ang imuhang kasugat, air ang imong kasugat. So it is a kind of friction. So kana siyang mga friction, mao na siya pwede maka-stop sa isa ka motion sa isa ka object. Okay? So kung wala na nato sila, then you will travel infinitely. Walay maka-stop sa imuha. So you will continue in motion in the same speed and same direction. Okay? So that is the answer for that. So next is slide a book across the table and watch it slide to a rest position. No? So slide a book across the table. Then kung tanaw nimo, i-execute nimo na siya. If you execute that, let's say you have a book. Okay, book. So kanina lang. Okay. Let's say we have a desk. If you slide it, ano, pwede na kita. Okay. So if this is the book on the desk, let's say my hand is the desk and this is the surface. Okay? Pag i-slide mo ang book, eventually, mo-stop na siya. Gamay akong hand, so wait lang. This is not a good... Asan na to? Okay. Let's get another bigger surface. Okay, let's say this one. Okay. Let's say this is the desk, okay? Um, say that you slide a book. Hindi siya makita. Okay, slide a book towards the desk, and eventually it will stop. Diba? So, gipush na ko siya, and it eventually stopped to a rest position. So, the book in motion with the tabletop, dili na siya nag-rest kay wala na ako siya gihatagan og force. No? Dili na siya nag-rest kay wala na ako siya gipadayon og force. No. But it is because of the friction between this surface and the book. Okay? So it is not because of the absence of the force, but rather because of the presence of another force, which is the friction. Tungod kay friction, mi-stop siya. Pero kung wala o nato ni ang friction between the surface and the book or the notebook, okay, then this notebook or this book, let's say this book, will continue in motion with the same speed and same direction. So, yung ana na siya. Okay? So, that is under the law of inertia. That is the magic of law of inertia. Okay? So, next we will have the free fall and air resistance. So free fall and air resistance, if you have remembered our free fall topic, permita mo ingon nga neglect air resistance, right? So we say Luke drops a roof tile from the top of his house. Gidrop niya. What is the final velocity of the tile? Tapos neglect air resistance. The acceleration due to gravity, or the G, is equal to 9.81 meters per second squared. No? So natay ginatawag nga neglect air resistance. So also may effect if naay air resistance sa atong free fall or free falling object or falling object. Okay, because in real life or sa atong makita diri sa earth, na magay air resistance. Okay, na may hangin, of course, no? So natay atmosphere, so na air resistance. But outside the space, walay air na pwede nila ma-encounter. So it means they can't free fall there, just like the moon, no? Wala may air, wala may atmosphere ang moon, or kung na atmosphere, it's very minimal, gamay ra kayo. So wala kayo sila air resistance na mahitabo, or wala air resistance na mutabo sa isa ka falling object dito. That is why it is in vacuum. So that is the pure nga free fall. Pero diri as sa earth, naman tay air, natay wind, no? Need man nato og air to live. That's why this scenario here in free fall and air resistance is what is happening on Earth, or objects on Earth. There is air resistance. So in the previous topics of free fall, it was stated that all objects, basta free fall, same na sila og acceleration. O sila acceleration? Negative 9.81 meter per second squared, which is the G. Okay? Which is the G. So, it means regardless of their mass, kung gamay man sila, kung dako man sila, they will have the same, they will fall at the same time. Same sa kanang situation before gali na, kanang mga situations na example sa una about the rock and the feather. Okay, the rock and the feather. So in free fall, they will land at the same time, even though they have different mass. They have way, the rock or the stone has more mass than the feather. So syempre, for you, the rock will fall first. Pero in free fall, dili day siya yung ana. No? So regardless of their mass, kung heavier ang object sa isa or dili, they will fall at the same acceleration. And hence, they will fall at the same time. Okay? Tungod ana ni G. So if you have remembered the free fall, the only influence that is acting on the object is the gravity. Wala siya. Influence. Gravity lang. Now in real life, in real life scenarios, we have air. So we have gravity and air that can influence our emotion, no? Vertical motion man na siya sa free fall. Okay? Now, let's go back to the free fall. So let's say that we have these animals. Okay, so we have the elephant and the mouse. Of course, if I'm gonna ask you which one is more heavier, you will really answer elephant, of course. No? Let's say that the mass of the elephant is 1,000 kilogram. And let's say this is a mouse, a very hip mouse. The mass of the mass of the mouse is the mass of the mouse is 1 kilogram. No? Let's say that our g is equal to 10 meter per second squared. Dali lang nato siya ma-solve. Okay? I-round off na lang nato. So, the 1,000, ang F-grab niya, which is the weight, daghan kayo na confuse ani sa free body diagram nga summative. No, wala gyud ko kasabot nga no ang F-grab na may sa left na F-grab na may na ay nasa left na ay nasa right na F-grab na ay na po F-grab nga naa sa taas. No? F-grab is your weight and it is influenced by gravity. Asa man din gravity padulong? Syempre downwards. Nganong naa may mga F-grab sa right na nag-drawing og F-graph sa ilang free body diagrams nga naa sa right, naa sa left, nga naa sa taas. Asa man di padulong inyong gravity? Kung mo jump day mo padulong day mo sa taas. Wala ba ya? No? So, FG is always going down. No? Yes, daghan na. Nag-check ko. Daghan kaayo. Okay. So, the F graph is your weight. Unsa man day ato ang formula kay weight, 'di ba? Weight, or also known as Fg or the F graph, is equal to the mass of the object times the acceleration due to gravity, which is, let's say, gitan nato siya para dali nato siya ma-solve. Okay, so what is the mass of this animal here? So it's 1,000 times the g, which is 10. We have the weight or the Fg of the object, which is 10,000. Okay, next is what is the weight or the Fg of the mouse? Then 1 times 10 equals 10. Okay, now if we are, remember that this is in free fall. Free fall sila. Nag-free fall. So it means it is only influenced by the gravity itself. So to find their acceleration, both of their accelerations, we can use the second law. Second law, remember pa, F net is equal to mass times acceleration. So para makuha si acceleration, ing ani iyahang pag-derive. Okay? Kinakakita ko og mga formula. Acceleration is equal to net force times mass. Di times ang net force sa mass. Okay? So if you are going to look for the acceleration, it is net force over the mass. Okay? Now, here, as you can see, ma'am, basta mag-ask mo, ma'am, nganong ang atong F net man kay 10,000, di ba F grab man na siya? Okay, here, di ba? So, dayo nga to ang definition sa net force. Because that is also the problem that I saw during our summative. Unsaon pag naglibog ang uban, sa unsa si net force. So, dayo si net force dayo. Net force, mo ni siya ang nabilin nimo nga force after all the forces are cancelled. Okay? Both vertical and horizontal. Cancel sa nimo ni siya si horizontal na mga forces, kung naay makancel sa ilaha, Kung dili ma-cancel, then kung i-subtract ba sila, i-add ba sila, then vertical tayo. So kung unsa tong nabilin sa ilaha, mauna siya si net force. Now here, we have only one force acting on your object. One force lang. Unsa man to? Free fall man siya, so ang gravity ra or the force ra sa gravity ang nag-act sa imuhang object. Wala siya normal force, ha? Dahil katong falling object sa ako ang summative na ay nag-normal force. Nag-fall pa man siya, no? So if it's in a state of falling, walay normal force. Wala man siya surface. Wala pa air resistance pa, ha? Wala pa air resistance. Gano'n man, free fall pa man. So the only influence is the FG, or the gravitational force. So here, since wala man siya kapares si FG, siya mismo ang atuang Fnet. Okay? Remember that, if walay kapares ang isa ka force, it means siya si Fnet. Okay, I hope that is clear. So that is why the Fnet is 10,000. Then you put the 1,000 na kilogram sa atuang elephant. Then 10,000 divided by 1,000 will go back to 10. How about the mouse? The mouse, the same formula. 10 ang iyang Fnet, same reason why 10,000 si elephant, no? 10,000 ang Fnet sa elephant, maupod ng Fnet ni mouse. Tungod sa iyang Fgrab is 10. Okay? So, maupod na siya, iyahang net force. So, 10 divided by 1, still 10. So, as you can see here, even though the elephant is more massive than the mouse, is actually 1,000 more massive than the mouse, pareho na sila og acceleration. Why? Because in free fall, walay labot si mass. Remember that. Free fall, walay labot si mass. So, what would happen if naanay air resistance? No? Sa free fall man gud kay ginal-neglect nato si air resistance. What happens kung naanay air resistance? Okay. So remember that in free fall, we only have the influence of the gravity. So the only thing that can affect your free fall or free falling na object is the gravity or the force of gravity itself. Okay? So the acceleration depends upon two factors based on the second law of motion. No? Pwede siya maka-affect si net force and si mass. Okay? But, diba, if you remember the second law, that acceleration is directly proportional to the mass and inversely proportional to, directly proportional to the net force. It is directly proportional, directly proportional to the net force and inversely proportional to the mass. So, if mag-double ang imuhang net force, mag-double pod sa acceleration. Pero pag mag-double pod ang imuhang mass, mag-half si acceleration. So, and that's what happens here. Ano? Kay elephant. Dako iyang Fnet, 10,000. Pero kay dako man pod ang iyang mass, so it becomes 10. Nag-equal ra gihapon siya diri kay mouse. Because even though mouse has a low or gamay ra iyang Fnet, gamay ra pod ang iyang mass, same na gihapon sa acceleration. So it means walay labot si mass, walay labot si Fnet. Okay? Just the gravity or the force of gravity itself during the free fall. Okay. Now, what about if na siya air resistance? Okay, so this is the reason why pag naanay air resistance, naanay mas mauna og fall kaysa sa just like here. So, tanawin na to ang JF. If they are falling at the same time, pero mas niuna si elephant o mas niuna siya og fall. Okay? Why? It is because of the air resistance. Air resistance, as an object falls through the air, it usually encounters some degree of air resistance. Air resistance is the result of collisions of the object's surface or leading surface, kanang nag-una niya na surface, and the air molecules. So the actual amount of air resistance encountered by the object is dependent upon variety of factors. It means ang iyahang ma-encounter na air resistance depende sa mga factors. What factors? So ang mga common na factors is ang speed sa object. Oh, naday siya sa kapaspason? Yes, because if there is air resistance, magmatter na sa speed. Okay? Then we also have the cross-sectional area of the object. The more nalapad siya, the more nam daghay air ang mo encounter niya. So that is the same situation as, a crumpled paper. Let's say we have two kinds of paper, same paper. Let's say bond paper. No? Naba ko'y bond paper din na masacrifice. Ayaw na lang. We have two papers. Ang isa kay crumpled, ang isa kay lay flat. When you let them fall at the same time, kinsa may muuna sa ilaha. Of course, the one that will fall faster is the one that is crumpled. Katong imuhang gi-crumple. Nga naman, mas gamay man siya cross-sectional area than the katong naglay flat or katong normal lang. Okay? So, that is why magmatter po ng iyang kalapad. Siyempre, kung dako ang or lapad ang isa ka area, daghan may ma-encounter na mga air molecules. So, mas maglisod daghan with more air resistance, mas ginapush siya pataas. More about that here. So, because of air resistance, the object will encounter or reach what we call terminal velocity. Ano na siya si terminal velocity? Sa day ng terminal. Dili ng bus. Daghay nag-ingon sa ako na. Kumana na nga joke. Terminal means last one. No? So, pinaka-last. Okay? So, it is actually, terminal velocity is actually the velocity that the the object reached. The object reached before magbalance ang iyahang air resistance na force o ang iyahang gravitational force. What does it mean, ma'am? Before magbalance iyang forces. Okay? So, as it is falling, magkapaspas na siya. Nga naman, kay need niya i-balance ang iyahang air resistance na force o ang iyahang F grav. And ang pinaka-last na velocity niya na ma-reach is what we call terminal velocity, just before mabalance niya ang duha. For example, here. In the diagrams below, free body diagram showing the forces acting upon an 85 kilogram skydiver. So the mass is 85 kilogram. No, equipment included. So for each case, we will use these diagrams to determine the net force and the acceleration of the skydiver at each instant in time. So same rin siya nga diver, okay? Same rin na siya nga diver kani sa diagram A, B, C, D, but different time. No? Okay. So in A, we have here. Maklaro ba? Okay. Sa A is bag-o pa siya ni ambak. Okay. So pag bag-o pa na siya ni ambak, it is in a state of free falling. So remember nato ganina, free falling, it means the only influence is the FG or the gravitational force. With that, para makita nato si FG, diba, remember ninyo FG is equal to mg over g. Over g multiplied by g. Now, the mass is 85. The g, let's say the g is 9.8. So, sa diagram A, the FG is 833. Ano siya diri actually? 833. So, since it is the only influence is the gravity, so the F net, sorry, the F net or the net force of diagram A is the F grav itself. Siya mismo sa F net, wa may lain na pares niya, no? Kaya wala pa may air resistance, kay nag-free fall pa siya, igo pa siya ni ambak sa helicopter. Now, on diagram B is after niya, naniambak na siya, so after some time, na siya na-encounter na air resistance. So, since bago pa man siya niambak, gamay pa ang iyang air na-encounter. So, here, we have a 350 na siya ha, nga air resistance, or the force of air resistance. And the gravitational force is 833 gahapon. So, pareho na sila diri ang 833. Kaya, syempre, di man magbago imong weight if mag-fall ka. Now, the air resistance is picking up force. No, so the more you fall, the more air molecules you will encounter, and when that happens, the more force of air you will get. So here in diagram B, you have 350 newtons. Your F grav is 833 newtons, and naa na sila let's say, nagpares na sila. So, since nagpares naman sila, malahi na imuhang net force. So, if in diagram A, your net force is 833 kay si FG raman ang imuhang force, in diagram B, your F net will be wala ba? 483. Your F net will be 483. In which direction? Of course, down. Down. Okay. It is downward. Ganun downward man. Okay, mas dako man si FG kaysa ni air. So it means, mas dako ang mabilin sa FG. Sa FG kung ano na to sila. Minus. Okay. So, the F net is 483. Since nag-change man ang iyang F net, mag-change, oh my God, mag-change po ang iyang acceleration. So, the acceleration, kung diri ang iyang acceleration is, because it is in a state of free falling, 9.8, iyang acceleration diri sa B becomes 5.68. Basi nag-wonder mo, nagyon sa nako ni siya pagkuha sa acceleration. Second law, F net is equal to mass times acceleration, or acceleration is equal to F net over mass. Mass is 85. Okay. Now, another time or another seconds passed, mas daghan pa siya air na encounter. So the force of the air becomes 700, and then iyahang gravitational force is 833 gihapon. So the F net here becomes 133. So since the F net change, the acceleration also changes. So the acceleration here in C becomes 1.56. Oh my goodness. Okay, 1.56. 1.56. 5 na siya, ha? Okay. 1.56 meters per second square. Okay. Then in diagram D, as you can see, nagbalance na sila. The air becomes 833 and the F gap becomes also 833. This time, before ni reach niya ni, diba? If they are equal with each other, the F net is 0 on D. Now, if the F net is 0, the acceleration is also 0. So from 9.8, nahimo siyang 0. Now, just before na 0, or let's say, just before nagbalance ang air resistance o ang gravitational force, naka-reach na na imuhang object sa terminal velocity. Okay? So, just before niya ma-balance ang duha, ang air o ang gravitational force, nagka-reach na siya og terminal velocity. What is terminal velocity? That is the speed or the velocity that the object reaches just before mabalance niya ang air resistance and the gravitational force. That's what it is. Remember that. Okay? So it means in every moment in time, magkagamay ang imuhang acceleration until it becomes 0. Remember ha, dili si velocity ang nag-0, si acceleration ang nag-0. The terminal velocity, siya ra ang last na velocity, pero it means naa kay velocity, dili siya 0. Okay? Naa kay velocity. Okay, so the diagram above illustrates a key principle that as the object falls, it picks up speed. As what we have said before, naagyapon siya speed. No, bu-pick up siya, so it means bu-increase ang iyang velocity until ma-reach niya ang iyang pag-balance sa force. So, pag-balance sa iyang force, it means naka-reach na siya sa iyang terminal velocity. Okay, so eventually, the force of air resistance becomes large enough to balance the force of gravity. At this instant in time, the net force is 0 Newton. The object will stop accelerating. That is why our acceleration here is 0. Dili na siya ma-accelerate. So the object is said to have reached the terminal velocity. Na-reach na niya. Okay? So the change in velocity terminates as a result. Wala na change, di ba? Acceleration is the change in velocity. No? Remember pa ninyo sa ako ang topic sa una? Acceleration is the change in velocity. Nag-change yung direction, nag-change yung speed. That means it has acceleration. Now, if, syempre, nag-reach naman siya og terminal velocity, what will happen? There will be no more changes in your velocity. And when that happens, your acceleration becomes 0. Balance na tayo limang forces. Okay? So the velocity at which this happens is what we call the terminal velocity. I hope that is clear for you. Now, ma'am, basta na mag-asa ko. Now, ma'am, wala ko kasabot na, o sa may point, ani. It's actually a proof that the more massive the object is, the more na mo land siya og faster. Asa man dapat dito ang naka-proof ato niya, ma'am? Okay, ano siya? The more bigger or the more massive the object is. Say we have 100 kilogram parachuter and we have 150 kilogram parachuter. Of course, the 150 is more massive than the 100 kilogram. When that happens, no, si 150 kilogram na parachuter will have a bigger F grav. Nga naman, kaya dako man iyang mass, dako po da yung F grav. You get me? Okay? So when that happens, mo pick up siya og speed. What do I mean by that? Kay dako man kaayo ang iyahang F-grav, dako ang ang needed i-balance sa iyahang F-air. So kay dako man ang ilahang need na i-balance, need nila og many speed, or let's say mas needed nila og daghan na speed, mas dako nga speed para lang ma-reach niya na nga force. So the more massive the object is, the more na dako ang iyang dapat i-balance. So usay ang buhaton, ipa-increase niya iyang speed. That's why mo land og faster ang massive na object. Ano man kay nag-apas man siya sa iyahang sa iyang pagbalance sa forces. Okay? So I hope that's clear. So the more with air resistance, the more massive the object is, the more it picks up speed, the more it will land faster. Just like the elephant, no? Nganong nauna man si elephant kaysa kay mouse, kay mas dako man siya. Mas dako ang iyahang needed i-balance. Gano man, di ba FG niya ato is 10,000 newtons. So ang air ato, need niya pod na muapas atong 10,000. So how can it, like, saan man niya pag-apas sa air resistance? Mo pick up siya speed. Magpaspas siya para dali niya ma-reach ang 10,000 newtons. Compared sa mouse. Ang mouse kay 10 newtons naman to yung F net or yung FG. So, relax na siya. Compared sa elephant. Relax lang iyang pag-pick up sa speed compared sa elephant. Ana siya nga sense. Okay. So remember that terminal velocity occurs when the air resistance force equals the weight of the falling object. Ma-reach lang si terminal velocity pag ang air resistance force mo equal sa weight or sa F-grav or FG sa isa ka falling na object. Means that the object is falling with constant velocity, its acceleration is 0. Sa terminal velocity ha, pag na-equal na nila. So pag na-equal na, constant na ang velocity. Wala na yung acceleration or 0 na ang ato ang acceleration. Heavy objects will have higher terminal velocity. No? Kaya taas man ang ilaha, dapat i-increase man nilang speed. Diba? So the more i-increase nila ang speed, mas higher ang ilahang terminal or last na velocity before sila before nag-constant before siya nag-constant kinabalance naman than the light objects. Therefore, heavy objects will fall faster in air than light objects. Remember that? In air. So kung walay air, ni nga siya vacuum, they will fall at the same time in vacuum. Okay? So this doesn't happen in free fall. Wala na siyang concept sa free fall. Okay, so I hope that is clear for you. Let's go switch to the next one, which is so next. Okay. The next one will be the application of okay. Next one will be the application of second law. Okay, there it is. So the application of the second law. Dili pa dito application to tong gibuhat ma'am na kanang nag-incorporate tag free body diagram sa second law nga formula. No, it is not application of second law. That is just the concept of the second law or the application of the formula, but not really about applying the second law to real life scenarios. Okay? Now, remember that in our free body diagram, ing ani pag-drawing sa ato ang free body diagram ha. Kaya naagyapon ko nakit-an na ang pag-drawing sa arrow is baliktad, pa-inward. That's not correct. Well, for this time, ingani yung sa nato siya. Okay? Hmm? Okay, anyway. Now, ang ato ang na-discuss sa free body diagram is just the individual system. What do you mean by individual system? Isa ra ka object. Diba? If you have remember, it is a combination. It is an individual system. Kano sa man to siya nahimong combination? The closer that we have encountered an entire system or a combination is katong combination sa gymnast and sa bar. That is a combination or that is a system. Pero naman po yung mga systems na medyo complicated than the other examples we had. For example, this one. This is a system. Natay duha ka bodies, two individual bodies, M1, that is M1 or mass 1, and M2. Now with this kind of system, the motion of M1 will affect M2. No? So naa sila'y cause and effect, no, ng mga relationship. So, kunwari hatagan nimo og force si M1, dili lang siya ang maapektuhan ani sa isa ka system. Pati si M2 maapektuhan po because they are part of one system. Okay? So, si second law actually will explain that part. Okay? Now, this is an example of application of the second law. The 10-kilogram object is resting on the horizontal frictionless surface that is subjected to two forces. Ingon siya, force 1, 30 newtons directed to the east. Okay, so 30 newtons directed to the east. If we are to draw that in our free body diagram, kaya hatagan naman tag force daan. So here, that is actually isa ra ka object ato ang gi-tan-aw or sa ato ang gi-observe. So it means it is just an individual. Individual ra siyang system. So since it is directed to the east, it is going to the right. $30 newtons. Okay? Daghan kaayoy naglibog aning daghan kay mga kulang sa kato sa summative na to, daghay kulang og units. Or na ako'y nakit-an nga force, gidrawing niya kay force, pero ang unit kay kilogram. Kilogram is mass. Okay? So remember that units have its corresponding physical quantity. Newton is force. kg or kilogram is mass. So ayaw og sulat og mass diriya sa mga forces na side. Asa man nimo ibutang si mass? Pwede diriya sa sulod sa imong box. No, pwede diriya. Pwede pod isulat rin mo siya. Mass is equal to blank. Pwede. Okay? So dapat wala ko'y makita na kg diri. Because that is not a force. Next is F2 is 50 newtons directed to the west, or it is going to the left. Okay, so let's say that is straight. Okay. So then, mao na pod ni ang ako ang nakitaan sa atong summative. After that, dili na nila sulaton si FG ug si F norm. Since this is this has actually has a surface. Okay, naa man siya sa surface. Na siya F norm. No? Naiuban na FG lang isulat, walay F norm. FG, F norm, or Fn. It's okay. So, niya siya dire, find its A, acceleration, and displacement 10 seconds, di niya makita, 10 seconds after starting from rest. Okay. So, ato ang information na atong given is 10 kilogram, this, two forces, and the 10 seconds. Pangitaon na to si acceleration o si displacement. Okay, with those information, we can put it here. Mass is equal to 10. Okay. Na naman dito. Never mind. Nasulat tayo na ko. So, we have 10 kilogram. Pwede mo po dire sa sulod. 10 kg. Okay. So, if we are to find its Fg, or its gravitational force, so that will be Fg times mass, Fg is equal to mass times the gravitational acceleration due to gravity, which is 9.8. So that is 98. 10 times 9.8. So kay naa man siya sa frictionless surface. Okay? Your Fg equals your F norm. No. Nay mauban na makalimot og butang sa ilahang F norm or drawing sa ilang F norm just because they have Fg. Okay? So, even though they equal each other out, dili nimo sila tanggalon sa imong free body diagram. No? Daghay na mali ana. Kay tungod sa balance sila, wala nila sila gi-appeal og draw. Pwede na niyo siya i-cancel. Basta kay present sila sa inyong free body diagram because even though it cancel each other out, they are still the forces that is acting on the object. Ayaw sila wala kay naaman sila daan. Na-cancel lang sila or na-balance lang sila. Okay? So here, since they are balanced, we are left here with the horizontal forces. So 50 minus 30, we have the F net of 20. Okay, asa man ang direction? To the left. Why? Because 50 is bigger than 30. So kinsa man ang naay bilin? Of course, si 50, which is on the left. Left na siya. Okay. Left or west because they stated here west and east. So pwede west. Pwede west di butang. Or west. Okay, since we have mass and we have F net, we can get the acceleration. So acceleration is equal to 20 newtons divided by 10. So it means your acceleration is 2 meters per second squared. Okay. Now, no. Okay. Now, since you have your acceleration, nakuha na nimo ang first nagipangita, which is A, its acceleration. Now, let's go to B, which is the displacement after 10 seconds after starting from rest. So what does that gives us? It gives us time, which is 10 seconds. Naanatay acceleration, which is 2 meters per second ganina. Nawala lagi. Okay, so ganun siyang acceleration, time, acceleration. Then, we will need the displacement. Then, ingon siya, it is from rest. So, kay from rest man, the velocity, that is actually a velocity, or particularly the initial velocity. The initial velocity is 0 meter per second. Okay, so saan man natin siya pag-solve? Remember that you have time, initial velocity, displacement, and acceleration. Asa man ni sila makuha? So if you have remembered, pwede nato sila makuha sa 4 kinematic equation. Yes, we will go back to the 4 kinematic equation. What are the 4 kinematic equations? So, ma'am, appeal ba ni siya sa, nabay, provided bang formula sa 4 kinematic equation? Yes, it is provided sa exam. Provided siya. Okay, so we have the first equation, that is displacement or distance is equal to initial velocity plus final velocity over 2 times time. Sorry for my handwriting. Okay, mouse ra akong gamit. Okay, 2 is the final velocity is equal to, so ito. Final velocity is equal to initial velocity plus 80. Okay, that's right. Next is displacement is equal to initial velocity times time plus na siya ha, plus 1/2 a t squared. Then we have number 4, which is final velocity squared is equal to, that is squared, initial velocity squared plus 280. So it means when finding the displacement may yung ipangita ganina, no, finding the displacement, we will use the 4 kinematic equation. So asa man diri ang naay displacement, naay initial velocity, ug naay time and acceleration. And that will be the third kinematic equation, or the d is equal to initial velocity time plus 1/2 a t squared. Okay, so here niyan ta na initial velocity is 0, so that is 0. So displacement is just 1/2 of your acceleration, which is 2. Then we have the time, which is 10 squared. 10 squared, then 1/2 of 2. So the distance, or displacement actually, is 100. So that is how you solve for the application of the second law. So medyo easy pa siya, no? So you just have to do this, then tanaw dahil sa 4 kinematic equation, if unsaon nimo siya pagkuha sa mga missing dayon na mga values. Here, like here, displacement. Next is, okay, bug. Okay, so if a force of 15 newtons directed east acts on a stationary 5 kilogram mass, what is its acceleration, displacement, and velocity after 10 seconds? Okay, so we have here another one. Okay, so niyan siya dire, na siya'y mass na 5. Okay, nagbag na po siya. Okay, 5 kilogram mass. Okay, sorry. Then we have a force of 15 newtons directed east, asawang east. So it is, kung we will, if we are to draw its free body diagram, it is going here. Okay? So, natay FG, of course, natay FG, kay naman siya mass, or it is an object. Then, naatay F norm, it is because stated here, it is stationary. Stationary, of course, it has surface. Then, we have 15 newtons. So, if your mass is 5, or FG is, not FG, 5 times 9.8. We have 49, right? Then we have 49 para dato ang normal force. Okay. So since this balance each other out, our F net is also 15. Ngano si 15 man, wala man siya niingon diri Again. Wala man siya niingon diri na ay partner si 15. Kanira siya. No? So wala siya niingon na ay partner na friction, wala. So it means siya ra isa. So the F net is the applied force itself. 15 newtons. Okay, so then we can get the acceleration by deriving the second law. So 15 divided by 5, that is 3. Okay, so naa na tayo acceleration. Muna siya dere, acceleration. Next is the displacement and velocity after 10 seconds. So since niingon mo siya after, this is the velocity that we're finding is the final velocity. Okay, so narrow acceleration. So that is 10 seconds. So since it was stationary, since it was stationary before it was applied by some force, on 15 Newton force, stationary siya una, so it means the initial velocity is 0. Okay, so we have to find the displacement, I mean. So with acceleration, time, initial velocity, we can still use the third kinematic equation. So na displacement, na initial velocity, na time, na acceleration. Okay, so displacement is equal to, since initial velocity is 0, so we are left with 1/2 AT squared. Okay, so distance is or displacement actually is 1/2 A, which is 3, time, which is 10, then squared. So do not forget that there is a square in this formula. Kaya mao na siya ang malimtan sa uban na naapay square diraa sa atong time. If you're using the third formula or the third kinematic equation, naapay square si time. Okay? So it means the 1/2 of 3 is 1.5 times the multiplied by 10 squared, so that is 100. So distance is equal to 1,150 meters. Okay, so that is your displacement. Next is ningon siya final velocity. So looking back to the four kinematic equation, bag again. Natay tulo na choices. We can use 1 because na siya final velocity. We can use 2 because of this, not the initial velocity, acceleration, and time. Pwede pod si 4. But we'll go to the easiest one, which is si number 2. Si number 2, kay dali na siya i-solve. Okay, ayan na siya palisod-lisurayin yung kagalingan. Okay, so final velocity. So initial velocity plus at, no? So since our initial velocity is 0, so we are left with acceleration times time. Acceleration is 3 times time is 10. So your final velocity is 30 meter per second. And that is how you get it. I hope that is clear for you. No? If you have questions, you may also contact me. Okay, so see, these are some of the applications. Napay other applications, natay practice questions. First is we have here, a waitress shows a ketchup bottle with a mass of 0.45 kilogram to her right, along a smooth level lunch counter. The bottle leaves her hand moving at 2.8, then slows down as it slides because of a constant horizontal friction force exerted on it by the countertop. It slides for 10 meters before coming to rest. So what are the magnitude and direction of the friction force acting on the bottle? So we are actually looking for the friction force. So medyo baliktad sila, no? Medyo baliktad siya sa duha ganina na questions. Ganina mo good is gi-fill out sa nato ang free body diagram to get the acceleration, and ang acceleration mao na siya idugang nato sa atong given for the four kinematic equation. Kaya siya medyo baliktad siya. Gihatagan sa ta og information to complete the four kinematic equation para makomplete nato ang free body diagram. Now, baliktad siya kasi sa ganina. Okay, so here, let's write out the given. Okay, so the given first is the mass. The mass stated here is 0.45. Okay, so we'll say this mass is 0.45 kilogram. Okay, next is we have an initial velocity. Na siya initial velocity, yun siya. The bottle leaves her hand, moving at 2.8 meter per second, then slows down as it slides because of the constant horizontal force. Then it comes to a rest. So it means initial velocity is 2.8, final velocity is 0. Okay, so that is what is mga hidden na mga given. So 2.8, and our hidden given, which is the final velocity, which is 0, kay nag-rest man, because it is resting. Okay, so unsay pangitaon nato diri napay given, which is it slides for 10 meter before coming to rest. Meter man na siya, so it is your distance or your displacement. Okay, so what can we do with this information now, the initial velocity, final velocity, and distance? With that, we can actually get the acceleration. Nga naman, because we need the acceleration to complete this free body diagram, diba? Need na to ang F-net, need na to ang F-net, need na to ang mass, need na to si acceleration. We have the mass, but we don't have the F-net and the acceleration. Now, dili nato makuha si F-net pa. Nga naman, because the F-net is the friction force itself as stated here. No? Friction force. Wala din siya applied force, ma'am. Wala. Nga naman, because it is already in motion. Do you get me? Wala siya counterpart, wala siya applied force. Nga wala man siya applied force because at the beginning, it is already moving. So an object in motion will remain in motion. So wala siya applied force, pero naa siya friction. So it means the friction itself is the net force. Hence, if we get the net force, makuha nato si friction. So it means sila last step na nato ang F-net. O sa may makuha nato sa ani nila duha, ang acceleration nila. Duha kanin sila ng mga given. Si acceleration nila. Because acceleration is part of the four kinematic equation. Wala mapud si F-net dito, di ba? Okay, so acceleration. So we will pick at the four kinematic equation that we can use nga naa si final velocity, si initial velocity, si distance, and si acceleration. Okay, so we can use the fourth. Final velocity, initial velocity, acceleration, distance or displacement. Okay. So Vf squared equal to initial velocity squared plus 280. Okay. So i-combine sa nato ning duha ka velocities. So we have initial velocity, final velocity minus initial velocity. Minus na siya, kay positive man siya diri, i-transpose nato to the other side, it becomes negative. So that becomes 2AD. The final velocity is 0, so that is 0 squared, meter per second squared, minus initial, or subtracted by the initial velocity, which is 2.8 meter per second squared, meter per second, then squared. Okay, then 2 acceleration, displacement of 1. So here it becomes 2a because that's just 1. 2a. Here it becomes negative 2, negative 7.84. So 2.8 squared is 7.84 because this is already 0. Meter squared second squared. Okay, I hope that's clear. Okay. So then, para makuha na si acceleration, we can divide those sides by 2. Okay, so acceleration is negative 7.84 divided by 2. So acceleration is negative 3.92 meter per second squared. No, negative lagi na siya. Yes, because it was stated here that it is slowing down. No? So slowing down man siya, it means it is decelerating. Diba? Deceleration is a negative acceleration. So tama imong answering, a negative dapat siya. Okay, so negative is correct. Or it's just moving to opposite to your motion. So mao ni siya ang ako ang iklaro sa inyo ha. No? So kung asa imuhang motion, pag negative gali na siya, ang imong acceleration, or ang imuhang F-net is, let's say, it is negative, it means ni-oppose sa imong motion, ang imong net force. Okay? What do I mean by that? Right here. Ingan siya dire. It is going to the right. The ketchup bottle is going to the right. So it means the motion is going to the right. So kung ang friction atong ginapangita, asa man padulong si friction. Remember that friction opposes the motion. Mo-oppose na siya. Na ako'y nakita sa summative, nagiuban si applied force o si friction force. Nga naman to. Nga naman to. No? Dili mag-uban si applied force o si friction. Mo-oppose na siya kay motion. So if your ketchup bottle is moving to the right, asa bang right? Para sa ako, dili akong right. No? So if it is going to the right, then the friction should be on the left. So pag mag-drawing ta, is it is going to the right, the friction should be here. F frict. No? So dagan sa summative ana katong sa car. Ngayon dito na ang car is moving, let's say sa right, moving to the right. 'Di ba? Na-discuss na ako na siya, if it is a car, wala na siya applied force. Just the friction. So friction is opposite sa iya sa movement sa car. Same situation here. If the object is going to the right, then the friction is going to the left. Opposite. Total opposite. Okay, so that is Fg. Just like air resistance. Oh my god. Air resistance. Ang air resistance mo-oppose pod sa motion. So if it is falling, it is going downward, of course. So the air resistance should be going up. So walay air resistance na going left and going right. Remember that the air resistance is a kind of friction that you encounter during falling. Okay, so when something is falling, muna siya si friction, si air resistance. Okay? Okay, but here this is not air resistance because it's not falling. So F norm ni siya dire. Ano F norm man? Kay naaman siya counter. Counter, that is a surface. Okay? So it is a countertop is a surface. So na siya F norm. Okay? So natay A, na natay acceleration. Now we will look for the net force. The net force, which is actually the friction itself. Nga naman. Okay. So what is our Fg? Fg nato is from this 0.45. So Fg is mass times G. If G is 9.81, no, G is not 8.20. No. Oh yeah. We can do that, or we can actually skip to the Fnet. Pwede na to siya Fnet, o pwede pangitaon ninyo si si Fg. But here, since it is on a counter, we should always, no, we will predict that Fg, atong i-guess na Fg and F norm is balanced. Mabalance nilang each other, makancel out nilang each other. Nga naman, it is because it is on a surface. So the Fg and the normal force is, they are equal. No? So si friction ra ang atong Fnet. Now we can solve the Fnet by the second law, which is mass times acceleration. Pila man natong mass? We have 0.45. Then we have the acceleration, which is negative 3.9 or 3.92. Okay. So your Fnet is actually negative 1.8. So meaning anong negative 1.8, ma'am? Okay, so nana po naglibog ani negative ang iyahang ari ang iyang situation. Negative ang iyahang Fnet. Yang answer negative. Pero gibutang niya sa right. Mali siya. Okay? Nganong mali man siya? Negative na gali. Kasi meaning anong negative? Negative means it is opposing the motion. So if motion is your motion is on the right, o sa may negative ana, ang negative ana is to the left. But kung nariningon siya diri, instead of right, it says moving to the right at moving to the left. So ang negative ana is going to the right. Okay? So ang meaning diri sa negative is ni oppose siya sa motion. Okay? It is opposing the motion's direction. So since the motion here is right, negative ang ato ang Fnet. So it means it is going to the left. So that's why it is here. Okay? So here, we have 1.8. Walaon na nato si negative pag i-drawing na nato siya sa free body diagram. Nga naman, because the negative there is just a direction. It just tells you the direction of your net force, which is on the left. Okay? So, I think magod na naglibog ang tanan. That is because sometimes the friction is on the left. No? So, dili siya nga na. The friction can be on the right. Pwede siya on the right if the motion is on the left. Pag padulong sa left ang object, then the friction is on the right. Kaya opposed man na siya, mo-opposite na siya sa motion. I hope that is clear. Okay? Okay, another one. So this means siya 65 kilogram skater moving initially at 2.4 meter per second on rough horizontal rise comes to rest uniformly in 3.52 seconds due to the friction from the ice. So what force does friction exert from the skater? So, niya siya diri friction apod. Friction apod ang iyang gipangita, okay? And ningon siya, it is moving initially at 2.4 meter per second. Initially, it means naana siya velocity daan. So pag naanay velocity daan, an object in motion will remain in motion. So it means that the friction will oppose whatever this velocity is going. Or mo-oppose siya sa direction sa motion. Okay? Pero here, wala siya i-identify kung, west, east, right, left. So we will go to the default one na pag wala ka siya giingon dira na sa direction niya. So we will go with the left kanang ang motion is on the right. If it is positive, the motion is negative, it is going to the left. Na mo default siya. That is the default. Na basta negative ang imuhang Fnet, it is going to the left. And if positive siya, it is going to the right. Default na siya. If you can only use that if walay gi-state nga direction, just like here. Wala siya gi-state. Wala siya ningon if it is going to the right, it is going to the left. So you just have to say that it's on default. No, default. Tawag. It means ang motion on default is going to the right. So, going to the right ang atong motion. So, it means atong ipangita nga friction is going to the left. Okay? Then we have the F norm because it is on ice, so na siya normal force. And we have Fg. And they cancel each other out. Okay? Next is natay mass nga 60 68.5. Okay, the mass is 68.5. Okay, so we will find the acceleration first para makuha nato si F net. So how will we get the acceleration? We will use the four kinematic equation by the given. No? So given nato initial velocity of 2.4. Okay, velocity. Next is 3.52. Okay, so we will put it here, 3.52. And then we have, sa pa. Okay, so ningon siya dire, maura na siya ang mga value, pero ningon siya comes to rest. So it means after the initial velocity, nag-rest siya. So the final velocity is 0. Okay, and then we'll find the acceleration. Okay, so final velocity 0, acceleration is missing or mao na tong ipangita. Okay, so with that, we can use the second kinematic equation. Saan na to? Okay. Second kinematic equation, which involves the initial velocity, the final velocity, the acceleration, and the time. Okay. So, wala man. Okay. So, velocity, ako na lang i-transpose daan sa initial velocity sa PCAS. Then we have a t. So, 0 is equal to the initial velocity, which is, sobraan. 2.4, 2.40. Then the time, which is 3.52. Sorry for the handwriting ha, kay nag-mouse ra gyud ko. Okay, so to get the acceleration, we can divide both sides by 3.52. So divide both sides by the 3.52. Kaya siya, negative 2.40. Oh, wait, not negative. 3.52. Okay, so cancel the side. Negative 2.40 divided by 3.52 seconds, we have negative 0.682 meter per second squared. Okay, so then we have the acceleration, which is negative 6.82 meter per second squared. So meaning anong negative? So it means ni slow down siya, ni decelerate. Okay, so that's what it means if the acceleration is negative. Ni slow down siya. Okay, so you just have to put it here on the acceleration. Do not forget the negative. Negative 0.682 meter per second square. Pwede mo po siya negative or pwede tanggalon nimo si negative and just put whatever the friction is going, which is ang negative side nato diri is ang left. Pwede nga nara. Okay, now for the F net, it is for getting the F net, so that will be mass times acceleration. So your mass is 68.5 multiplied by negative 0.682. So that will be negative 46.7 Newton. Pwede negative 46.7 or pwede po 46.7 going to the left. It means the friction here is 46.7. Okay. So I hope um that is clear for you. If you have questions, you may contact me. No? So, mo na sila ang actually daghan kay pang skip if you have remembered if you have seen my PPT, daghan kay pang skip. Okay? So, that is because they won't come out sa to ang exam. So, gipang highlight ra nako kung unsay possible na mugawas sa exam. No? So, those applications, yung application. Then we will proceed with the third law of motion, which is on the next video. Okay, so dapat ni siya nga nani. But this one is a bit harder kani elevator. No? I will discuss it on the other time. But this is different from the other applications. Medyo different siya. This one too. Okay, siya. And there's something bugging. Then siya accelerate. This is accelerating elevator. Usually elevators is a bit complicated. So I will discuss that sa sunod. Okay. So the next one will be the third law of motion, but I will just cut the video here para medyo gamay ra ang gig. Kasi medyo dugay siya ma-upload if dagko kayo ang oras sa video. Okay, so that will be all for today. See you on the next video explaining about the third law of motion. Okay, explaining about this. Okay, so and then actually tulo ka videos ang ako i-upload ron. Isa is isa kanina first part, then the second part is the third law of motion, and the third part is I think I will have a bit of review, not entire na i-review na ko ang tanan nagigit pang ano na to, but about say focus niyo. Okay, say focus niyo. Or maybe isagol na lang ako siya sa third law of motion kato siyang third video. Okay. That will be all. Bye.